All right. Please enjoy OBS. Having a good time. I got Eloise with me as always. And let's get started. Okay, so this is the second video in a series where we are creating a domain-specific language for UI testing in Rust. In the last video, we basically went over the problem description. We talked a lot about Cucumber and Gherkin. Hello. And ways we thought we might improve. And we talked a little bit about an existing RPA scripting language called TagUI that we're going to be drawing a lot of inspiration from for our syntax for the language. Now what we want to do is we want to get a lot more specific, and we want to try and come up with an initial language specification, at least a partial language specification, so that we have something that we can start implementing. And then, time permitting, we'll maybe try and get started coding and start working on a scanner. After looking at some of the, what sort of language we were going to be going for, I sort of decided it wasn't going to match up very well with RyScript, so it would have been fun to try, but I just don't think it was a good fit in this particular instance. We may still end up doing a procedural macro that takes our language and turns it into executable Rust. I think though the way I want to start out is building a sort of simple, a sort of simple interpreter so that we can run our script from the command line. And then in future videos, maybe try and embed that within a procedural macro in the case that we wanted to include our testing script in a Rust project. But yeah, so let's get started. So let's talk about language features that we definitely want. Okay, so what do we need? Well, we're going to need something for locators. If you've done anything with web automation before, everything you do, every action you take sort of comes in two steps. Locate the element you want to interact with, and then do something with that element. So the first thing we need is locators. We need a system for locating web elements on the page. And we're going to be taking some inspiration from TagUI. So let's go look really quickly at how they do locators. So TagUI is, again, it's a great little open source tool for RPA scripting. You could probably use it for testing. I don't think it's designed for that. It doesn't have a ton of testing utilities built around it, but I think you could use it for testing if you really wanted to. But it is absolutely great for robotic process automation. If you want to put together, a series of scripts that interact programmatically with UI, and it does more than web automation. It does desktop automation. It does visual automation, and it uses computer vision so that you can take a screenshot of something and say click that. And then it also does OCR, optical character recognition. But yeah, so the way TagUI does its web locators is basically when you pass a locator to a function, it goes through a list. It goes through a list of different types of locators it might be, and it tries to locate an element that way. So the precedence in TagUI, as you can see here, this command tells TagUI to try to click on any element which has getting started as its ID. So the first thing it looks for is an ID attribute on the element of getting started, and then it looks for a name. Right. This is if you've worked with locating elements before, these are both almost certainly, if you're doing your web design right, these are both unique ways to identify something. ID is unique because that's what it's meant for. It's supposed to be a unique identifier for the element. Sometimes you also have these things like test IDs or, that come with your framework. And then name is almost always unique because it's usually used with forms for sending information to like a backend in some way. Then after that, it looks at the classes on the element, and it says it is, is this one of the classes on the element? I don't think it's not just matching the entire class attribute. I think it's saying, does, is one of any of these classes the one I'm looking for? And then it looks for a title attribute. You don't really see title attributes in the wild that often, but they're basically sort of a way to, you can hover over the element and it comes up and gives you some information about the element. We're gonna try and flip this around a little bit. And then the last thing it looks for is if none of those match, then it looks at the actual text of the element and it tries to do that. I think we want to flip this around. Part of the goal of this DSL is that we want it to be a language where when you have a test suite, that test suite can sort of survive a rewrite of the application, or at least large chunks of it can survive a rewrite of the application. Basically, if you have say you've got an application in Angular and the development team decides we're going to rewrite it in Vue, they've been convinced to rewrite the website. The goal is that our tests are sort of going to survive that change. Also, we don't really want to be diving into like complex HTML too much. We don't want to be using XPaths if we don't have to. We don't want to be doing CSS selectors if we don't have to. We really want this to be a language for, basically where a manual tester who would not describe themselves as a programmer can pick it up and go, oh, I can get some stuff done with this. So I think we're going to flip that precedence around, and I'll talk a little bit more about that later. Okay, and then after locators, we need common web actions. So we have to be able to click stuff, we have to be able to type into form fields, we have to be able to scroll to certain places on the page, scroll things into view. I think we're going to provide, a sort of a small subset of these actions. We don't want necessarily every web action possible. I think what we want to do is we want to cover like 90% of use cases. After that, we probably need the ability to read text to a variable. So again, we're taking inspiration from TagUI. They have this read step, right? And basically what you can do is you can give it a locator and then give it a variable name, and it will basically locate the element with that locator, and then it will get the text from inside that element, and then it will read that, it will save that text as the value of some variable. That's pretty darn useful, especially if you're writing longer scripts, and you're working with things that are dynamically created. So maybe you're testing for eBay or something, and when someone places an order, they get an order ID, right? That order ID is dynamically created. You can't predict what it's going to be. So what you have to do is you have to read it in and save it if you want to use it later to say, look up the receipt for that order or whatever. So we're probably going to need some way to do that. I don't think, in terms of variables, I don't think we're going to have any sort of concept of scope. I think we're really just going to stick to global variables. A variable can be one thing at a time. Because I think if we start getting into like implementing like local scopes, then we're approaching the territory of a scripting language, of a like a Python or a JavaScript type situation. Similarly, we probably want to have some concept of procedures, or they would be called functions in most scripting languages. I don't know how complex we want these to be. It may be the case that we don't even want to pass parameters. We may just want to have the ability to have a chunk of commands and say run those commands again, you know. But we'll see. We may have a more complex conception of a procedure or a function. It just depends on our needs and our exploration and discovery in the future. Similarly to that, we might want to do some sort of concept of page objects. The page object model is super standard in automated QA testing, and I think a lot of places are going to say if we can't do the page object model, we can't use this tool. That's they're sold on that style of testing. I don't know that I'm equally sold, but nonetheless, we'd almost definitely want to support it. Probably not in the object-oriented sense, though. So we're not going to be. I think it's too complex to sort of add this something equivalent to a class where you can have something equivalent to a page class where you would have like locators as members on the class and then some sort of associated behavior. I think that's too much. I think if we add page objects, what it's gonna look like is more like a module of variables, so that you can just sort of have a couple different XPaths that are, or a couple different locators that are associated with each other, so that instead of having to retype the locator each time, you can say login dot username field, login dot password field, and that will sort of resolve to a predefined locator. Yeah, so those I think are the language features we really want to start with, and we may not even, we may start with everything but procedures and page objects and then get to page objects and procedures later. Let's talk about environment features, because we need more than, we're doing more than just a syntax. So what do we want our language to do? Well, we definitely need some sort of concept of reporting. The whole point of this is that when you run a test, it generates a report and says, these tests passed and these tests failed. I think the approach to this is going to be the same as just about every other tool. We're going to want sort of simple command line logging, and then we're also going to want to produce probably like some sort of JSON output, so that people can integrate these test results into their own reporting tools or build their own reporting plugins or whatever. But we also probably want just a sort of default HTML representation of a report, so that if you just want to run it and get a report and you don't care what it looks like, then we'll have one for you that looks pretty decent. We also, I think, are going to want some concept of error handling. I think some people might disagree with me on this. There's this idea that, especially with UI testing, your tests need to be short enough to sort of like to stand on their own, and if the error, it's no big deal. So you're not supposed to have a test that depends on another test succeeding in order to run. And if that sort of behavior is discouraged, then you don't have a need for error handling, because if one test fails, it shouldn't affect another test. I don't think that's necessarily realistic in the case of UI testing. I think sometimes you want to run a big, long flow, and you don't necessarily want it to peter out in the middle. Right? So if you're testing, a user story that's really, really long, right? You fill out 3 forms and sign up for a different account or something like that. Each step is dependent on the next. I think you want to have some concept of error handling. So the way this would usually be done is each of those steps would be done as an individual test, and then the precursor steps to that would usually be handled by an API call, just so that it runs faster, right? Get your requirements out of the way with an API call, and then only use the UI to test that one small portion. We're going to have some support for API calls, I think, but we really want to limit that because, again, this is supposed to be a language for people who would not describe themselves as programmers. So I think we're going to have some sort of concept of error handling so that you can do a long flow, and you can say, if this doesn't work, maybe try it again. Maybe the load time was off, or if this doesn't work, maybe my dev team or maybe you have a programmer on the QA team has provided a sort of replacement API call that's equivalent to the UI step. So you can say, if this step of the test fails, then go ahead and do the API step so we can continue with our flow, so that we can test these other bits of the flow, and then just come back and worry about that one step. So I think we're going to need some concept of error handling. Similarly, we're going to want some sort of way to do HTTP requests. And I think this is not something where I think if you're performing an HTTP request against like an internal API, it's totally fair to expect people to be able to program to do that. So I think what we're going to want is some way to drop down into Rust, maybe drop down into something else. Maybe we'll use curl. We'll execute a curl command or something like that. Just have a way to drop down into executing an HTTP request, and probably some way of having like a programmer come in and build supported HTTP requests for the language. So they could build out like the rest assured, or the in Rust we'd probably end up using a crate called request. Just build whatever your HTTP client is, be able to build pre-made requests for testers, and then testers can just access that request from their script. And then we are definitely going to want to have some sort of concurrent execution. I think eventually we'd want support for parallel execution. We're going to be building this on top of Selenium and Selenium Grid. So it should be fairly straightforward to map these scripts to the same, like architecturally it's not going to be any different, hopefully, than operating a Selenium Grid. We're going to start with concurrent execution. That is, we're basically going to have a standalone Selenium Grid on the local computer and just register drivers against it. But then eventually we'll probably want to add documentation and support around executing tests in parallel on multiple machines. Okay. Well, I guess I don't have to put that back. So what the heck is this actually going to look like? Like, based on that description, what is this language actually going to look like? I think it looks something like this. I think this would be a fairly standard, the example for these sorts of automated QA is always a login screen. It's just the most straightforward example. So I think this is what we're going to want our users to be able to write. So locate username and type at test@test.com, right? So we have this command locate, and that's going to handle resolving some sort of locator to an element, right? And the idea is that we'll have these precedence-based locators like we talked about earlier. When I said we were going to flip them around, I think we want to focus on things that a manual tester would see first, because those are the things that we want to that should really be the same even after a rewrite, for the most part. I mean, obviously, if they change the UI completely, there's nothing you can do. But if they're sort of rewriting underlying technologies, then hopefully, quite a few of these tests should be able to survive. So I think what we're going to do is we're going to prioritize, human readable, without looking at the HTML, just sort of human readable attributes of the element. So we're going to start with the text of the element. If the element's text that's displayed on the screen says the thing, That's what we're clicking. Similarly, we're going to do placeholders, right? Oftentimes, we're going to be typing into input elements, and so if that input element has a placeholder called username, and then we say locate username, that's probably what we're looking for. We're also going to look at adjacent label text. So, when very often in an HTML form, you have a label, and then you have a label and then an input. So we're going to say, hey, is there an associated label for this input? We might use the for attribute. Not everybody uses that correctly. Especially, not all CSS frameworks use the for attribute correctly. So it's very possible we'll just go with an adjacent, a preceding label. Is there a label that precedes this input element with the text that we're looking for? Then we'll go with that. And then we'll drop down into HTML. Then we'll look for things like ID, name, title, and then finally, I think we'll probably default to XPath. We might decide to do CSS locators instead, but one or the other. The idea is that even though XPath is obviously, the most dynamic way to locate your elements, basically, you're always going to be able to find your element with an XPath, but it's sort of brittle. It's more likely to break. So we want to discourage the use of HTML content and location on the page, and we want to encourage visible, seeable things. Okay, so that's operator precedence broken down. And then we're going to have this little combinator, this and keyword, and basically we want it to short circuit. So if locating username failed, then we don't want it to execute the subsequent type command. This is why we chose to do it this way. So TagUI does it a little bit differently. All of its commands, you start, most often you start a statement with one of these commands like type or read, and then you give it a locator, and then you give it, a destination, or in read's case you give it a destination. In type's case you give it the text you want it to type in. We're sort of flipping that around. I'd rather keep this separated into two steps. One, for error handling reasons, and two, just because I think it's good to think about. I don't think that's I don't think that's something we need to hide away. I think those should pretty much always be two separate steps. So basically, if locating the username fails, then the second part of that statement, the type test@test.com part, should not execute, and that's pretty standard for an and statement for a programmer, right? It's short circuiting. And then we move on, right? Then we locate password and try to type password 123 exclamation point in here. Another thing I want to say is we generally, I think we want to go with sort of high-level defaults rather than a lot of ability to specify. So for instance, in TagUI, when you type into an element, you can add this sort of clear command so that it will clear the input before you type into it. I can think of almost no instance where we would have some information already typed in and we would want to type more information in. So I think we're going to have clear as a default, and maybe have a command, maybe if someone asks for it, we'll add a don't clear command. And then we're going to locate the login button and click it, right? So if we don't successfully locate the login button, then we're not going to click it. But if we do successfully locate it, we're going to click it. And then we have this error reporting statement. So I was thinking about this, how to do the error handling. And I didn't want to do a sort of try-catch situation, because I think as soon as you start indenting, people feel like they're programming, if that makes sense. I don't want people, tabbing in 3 times and having a bunch of try-catch layers. So what I figured was we don't actually need an incredibly complex error reporting apparatus. I think we basically just want to have some sort of global error reporter. And if one of these expressions, fails to evaluate successfully to something, so like if locate password fails, and this statement short circuits and it doesn't type anything because it didn't find an element to locate to it. I think what I want it to do is I want it to report to an error reporter. And basically that error reporter will have a flag in it that, basically remembers that it had an error. And then it will have a sort of string that's equivalent to the last error that happened. So in this case, if locate password fails, then I want it to flag had error to true, and then I want it to save a string that says like, fail to locate element by locator password. And then, regularly throughout the script, we can sort of loop based on that. So in this statement, it says, if had error, then report error status and refresh and try again. This if had error then syntax, that's basically, I want that to be syntax sugar. So I want this to be equivalent to, sort of desugar to had error and. So basically had error is going to be this sort of global variable for whether or not we've encountered an error since the last time we checked. And then it will do, if that's true, then the following commands will execute, right? This and will, short circuit if there was no error, right? Because this would be a false, and so it doesn't have to check this. But if had error is true, then we could, then we do the rest, and we could say have a command for reporting and have that sort of saved error status. What was the last error? And then we have, chain another command for refreshing the page because we're going to try this again, and then chain another command for trying again. So the way I want this to work is when locate password fails and the statement short circuits, I want it to jump down to this next had error line. And it'll say if had error then, but really it will have, grammar-wise, it will have desugared to had error and. So the user will be able to write if had error then, and then so it will come down to this line, and it will run this operation, and then when try again gets called, it's going to go back up to the last had error line and then start executing on the next line. Or if you get to the top of the file, start executing on the next line. So the idea here is that it would, report the error, and then refresh the page, and then when you call try again, it would jump back up here and start trying to locate the username again. And then I think, like it says over here, we probably want that to only loop one time. We don't want to let people like trap themselves in infinite loops. But at least at least the ability to try something again once, because sometimes you just get a really slow request. Sometimes it's not necessarily, you could consider it an error, but it's not the error you're looking for right now. So I think that's a sort of ability we want to build in. And then after that, we're doing basically the same thing: locate dashboard container, and report successfully logged in. And then, if had error, then report error status and screenshot, right? So I think this is fairly straightforward. I think it's something that you absolutely do not have to be a programmer to understand and author. But nonetheless, I think it's something specific enough that we can execute it. So I think this is the middle ground we were looking for. So let's talk specifics. Let's start with a sort of an initial unofficial grammar for our language. So we start with this idea of a statement, and basically a script for us is going to be just a series of statements. Because remember, we're avoiding indenting by not, by the way we're doing our error handling. A statement is basically going to be an expression, some sort of whatever an expression is in our language, and then followed by 0 or more and keywords, and then more expressions. So you can give a command, you can give an expression, right? And then optionally you can say and then give another one, and then you can say and give another one, and you can do that 0 or more times. That's like locate. So in this sort of grammar, do this. So this is an expression, and then we're allowed to say and then do another expression. So this would be an expression, right? So what is an expression in our language? I think an expression in our language should basically always be a command and then 0 or 1 inputs, like an optional input. I don't really want to have commands that take like 16 inputs to them. I really want to keep it simple. So I think a command is going to look like this. So inside this expression we have, or an expression is going to be a command like locate, right? And then optionally some commands will take inputs like this username string, and I think that input is almost always going to be a string literal, either a string literal or some kind of global variable that we can resolve, like had error, right? So remember, this if had error then, we want that to desugar. Get out of here. We want that to, oh my gosh, are you gonna let me? Okay, it's not letting me type. Remember, we wanted that if had error then to desugar to basically had error and, right? If had error evaluates to true, then we're going to evaluate the rest of the statement. But if there was no error, then we're going to keep going. So I guess in that case, if we do had error and, then we could also have, so our grammar is not necessarily a command and some input. It could also be, actually, let's escape. In that case, right, we could have a command and some input, or we could have some kind of global variable. But in that case, in that particular case, we're always going to want it to resolve to a Boolean. We might have some work to do around the grammar specification for that, but we'll figure it out. And then we have, we have a series of built-in commands. So we have locate. Locate is the command that's going to take some sort of locator for a web element, and then go through our precedents and try and find what it is we're actually trying to interact with. Report is going to do exactly what it sounds like. It's going to take a message and it's going to add it to our reporting. It's going to pass it to our reporting interface, whatever that ends up looking like. We're going to have click, right? Type, refresh. Almost always going to want to refresh the page. Try again is going to be sort of this sort of token for going back as part of error handling. Screenshot, you have to have the ability to take screenshots for your testing. We'll probably add more to this list. Again, this is not official. We're gonna, I think, as far as visiting a URL, we'll probably take the same approach that that TagUI does. Is if you type in a URL that starts with HTTPS, then it's just going to visit that URL. And then as we go, we'll just realize more things that we have to add. I don't think we're not gonna try and get everything perfect up front in the scanner. and then everything perfect in the parser. We're just going to add as we go, as we remember things. For instance, we're probably going to want the ability to do things in a new tab, right? Sometimes you want, if you follow through a link, you kind of want to follow that through in a new tab. Then once you're done doing whatever it is you were doing, you want to close that tab and go back to where you were. In TagUI, that's sort of they have a pop-up command, but it's, to be honest, it's a little bit clunky to use. So I think we'll maybe try and come up with something a little more that gives us a little more control. So I think the way in TagUI it works is basically if you click a link and that link causes a pop-up, you can sort of say pop-up, and then TagUI will know to switch over to the associated new tab. I don't think we want to do that. I think probably when we're going to want some sort of command that's like click through. That's basically going to be equivalent to a control click action, so that whatever you end up opening, you end up opening it in the new tab. And then we're going to have inputs. Inputs are things that get passed to these commands. So you're going to have some kind of probably going to want to have string literals, right? Just something between two quotation marks. We could get rid of these string literals. Like if you look at TagUI, it doesn't have quotation marks for these things. So the command type knows that what it's taking is some locator, and so you can pass it some input, and it will be like it will determine whether that's a variable or whether that's actually something it needs to just some text. I don't really want to deal with all that. I really want to know as soon as possible whether something's a variable or some text that I'm supposed to evaluate. So I'm having us use quotation marks. I don't think it adds that much complexity to the language. Yeah. So I think that's what we're gonna do. Let's see, where are we at time-wise? I'm new to OBS. How did I tell how long I've been recording? I have no idea. Oh wait, here we go. 37 minutes. Okay. Yeah, what the heck? Let's start working on a scanner. I'll check my phone really quickly. Feel free to go get coffee. Oh Lord, 26 messages. Okay. Let's start working on a scanner. So I've made a little I made a repository for this project. Basically, I'm calling it Schnauzer UI after this sweet girl right here. So all I have in the repository right now is I have a git ignore that's sort of set up standard for a Rust project. We may actually change that up. It may be the case that we want to have multiple crates in this repository, right? Have a crate for the interpreter, and then have a crate that exposes a procedural macro with which you can use the interpreter. But we're gonna start off with just using a single Rust crate that has a library and then some binaries. And then I have a license in here, just the default MIT license. If you know a lot about open source licenses, and you have some reason why I shouldn't use MIT license, please tell me. I just don't know. I've always been told that MIT is the free one. MIT is the one that lets everybody use it. If you have a better license for me to use, let me know, and I will look into it. Okay, so here we go. I've sort of cloned the repository. Here's the license. Here's the git ignore. And I think we're going to start. I'm going to start by initializing this as a library. So we're going to cargo init --lib. Yeah, right. So we've got a cargo.toml, and we've got a source, right? Okay, so they've sort of Cargo's updated itself. It used to just give you this test module, and now they give you this little add function. I don't know who. I like it. I guess it's fine. Okay, let's go ahead and add some dependencies we know we're going to need. So we know we're going to end up needing 34, right? This is how we're going to end up. Oh my gosh. This is how we're actually going to execute our code. So when it comes to once we've lexed and parsed our code, that means once we've turned it into little tokens, and then once we've turned it into a little tree of tokens that we can walk over and figure out what it means, then the way we're going to run it is we're going to translate it into 34 code. So we're going to need 34. So let's add that. Probably going to use the async client. It does have asynchronous client. Cargo add 34. And then, and other than that, I don't know exactly if we're going to need anything else starting off. Yeah, I think that's good to get us going, and we probably won't even use 34 today. Okay, so let's start off with. Let's go ahead and structure our project so that we have a library and a binary. And basically what we're going to do is we're going to have a sort of main class. It's going to look a little Java-y, but we're going to have a sort of basically language runner class in our library, and then we're just going to call that from our binary. And that way, if somebody wants to use our language as part of some embedded system, they can just have this sort of interpreter, even a higher level object than the interpreter. They can just have this sort of language runner object so that they can pass it a string and run the language without having to actually use the binary from the terminal. So let's do that. And I always forget how to do this, so I'm just going to Google it. Like every time I just Google it, cargo lib and bin, right? And I know it's just like one line, but you can see it's purple because I do this constantly. Yeah, so you specify where your lib is, and then you can specify multiple bins. So let's do that. Let's go to cargo toml. Yeah, so I'm gonna have the lib called lib, or well, what do we want to call this? Let's call it schnauzer UI. That's what we're calling this project, by the way, after Eloise. And we're going to put it in source librs, and then we're going to have, let's call it command line runner. Yeah, command line interpreter. Basically, all the binary is going to do is it's going to let us, in the command line, run the program and give it a path to a script file, and then it's going to pass the text of that script file to our actual runner class that lives in the library. And we're going to call it source. We're going to call it. Let's actually have a folder called bin, and then let's do CLI runner.rs, and then we'll call that. Or we'll just call it CLI.rs. Let's do that. Source. Let's in bin. CLI.rs. Why are you? Yeah. Okay. Main function. Okay. So we need a main function. Function main. And then we're gonna have. Why are you mad? Expected up. Block. Am I crazy? What's going on? Oh, okay. Just Rust analyzer catching up. Okay. Let's do in our lib. Let's get rid of all this, and let's go ahead and just have a pub function run, and that's going to take some code as a string. And for now, all we're going to do is we're just going to print out the code. Right? Okay. And then in CLI, what we want to do is we want to scan in we basically want to read in the code from the file. And we want the file to be passed in as a command line argument. And then pass it on to the library. So let's do that. So what is it? Standard environment args. Let's file path equal standard environment args. Yep. Dot collect. We'll do let args first, right? We kind of want to. We're not going to add a ton of error handling right now or anything. Later on, we might add we might use clap or something to do a nice little CLI. But right now, we're literally just going to take in a file path. But we're going to say if args.len is not equal to 1. And here's a question: is this going to be like? Is this going to be like C, where the name of the binary counts as an argument, or is it going to be like Java where it doesn't? We're gonna assume it doesn't, and then if it errors out on us, then then we'll fix it. Println actually. Println usage, and let's see, what do we want to call the produced binary for this? Like when we package it, we'll call it schnauzer UI. So SCHUI. Yeah? We'll handle that at a later date. Usage, whatever the name of the executable is going to be, and then we'll say file path. Yep, else. And in fact, we should just do that. And if we are correct, then we're going to want to say, we call this function run arg0. And then let's import run. Cannot move. Oh yeah. We want to do get 0 dot unwrap, right? Dot to owned. Cool. Let's run that. Let's give it a test file though. Let's do scripts, right? And we're just going to do, I'm going to do a scratch script. Where basically we're just going to update this script as we go along through development, and then we'll start building like some regular testing script, sort of suite of scripts for testing. What do we want our file extension to be? That's a good question. Let's do SUI, schnauzer UI. Is that a common file extension? .sui extension. I just want to make sure we're not. SUI wallet, some Web3 crap. .sui file as a suit library. .1. I don't know what this is. We're going to go with SUI, and if somebody comments and says this is a thing that people use all the time, then we'll change it. We'll maybe search marketplace. Move syntax. Yeah, sorry, if you don't have an extension for your, if you don't have, highlighting for your file extension type in VS Code, then we don't care. Okay. Let's do test script. Obviously, it doesn't have to be valid yet because we're just printing it out. But we'll just say loaded script successfully, right? And then let's cargo run. And because there's only one binary, it should run the binary we have. And then that's going to take, take a minute to compile 34, even though we're not using it yet. People there's this enduring stereotype that Rust programs take a long time to compile, and that can still be true if you have like a huge, a production level Rust code base. You're going to have to put some work into your compile times if you're constantly recompiling as part of like CI/CD practices or whatever. But for the most part, it can take a couple minutes to do. We'll talk about that in a second. Am I even sharing? Can you see? Just want to make sure you can see my screen. Okay. For the most part, it can take a couple minutes to compile at first, but then the incremental compilation is really, really good. So it's just not really a problem in practice for me, at least. Okay, so it printed out the name of the executable. So that's an issue because let's look at something. Let's just do print line, and let's run this again. So args.len is 1, right? Oh, because I just said cargo run. Okay, I'm getting it now. So it's definitely got to be 2, right? It counts. It's like C, and we want to do cargo run with /scripts/scratch.sui, and we're still printing out that, so we want to do 1, right? So there we go. Okay, so we're getting the file name. Now what we want to do is we want to load the text of this file name. So I think it's read file to string. Let's get rid of that. Let's do let file path equal that, right? And then we're going to let the code be standard fs read to string, and then we give a file path. Cool. File path. This. Let's expect. I mean, obviously, we're not implementing our good error handling yet, but let's at least just say, hey, error reading file. Error reading file. And in fact, let's do a format string and do that. And then we'll run the code. Yeah? Borrow, Loaded script successfully. So you can see what happened was we ran it and we gave it a file path and it went into this scratchui file and it read the text and then it printed it out for us. Okay, cool. Now we can start in lib. Instead of just having this run function, we can have a sort of like a main class. Really, I guess we can start with a scanner. So let's do new file scanner.rs. So what we're going to be doing is what we're going to try and start doing is the scanning process. Sometimes it's called lexing. I think the best way to describe it is tokenizing. Basically, what we want to do is we want to take this list of characters, right? This list of like letters and numbers and spaces and whatnot, and turn it into valid tokens for our language. You can think of it like valid words for our language. So if we go here, if I just look at this statement, if is going to be a token, had error is going to be a token, then is going to be a token. And so this is going to be like just a keyword, just a plain old keyword, same with this. But then had error is going to be, you know, a variable token, and we're going to sort of resolve that to a variable later on, to some value later on. And like a string literal, that's going to be a token. So basically what we need to do is we need to write out all the different kinds of tokens our language is going to incorporate, and then we need to write a program that walks over our script and sort of builds this vector of tokens. So let's do it. You know what? We are getting to, yeah, this is 2 minutes away from an hour. So let's do it when we come back. See you next time.